Hey everyone, welcome back to another CodeSpector data structures video. In this week's video, we're going to talk about a special type of binary tree called a heap. If you aren't familiar with binary trees yet, I suggest checking out our binary tree video that we did early on in our Typescript data structures series. I'll put a link to that video in the description. If you look at a visual representation of a heap, you'll quickly see that a heap is just a binary tree. However, a heap is a special type of binary tree that is called a complete binary tree. A complete binary tree is a binary tree in which all nodes are completely filled at every level except the last. And on the last level, all of the non-filled tree nodes are as far left as possible. In this circumstance, being completely filled means that each node has two children nodes, unless you are on the last level. On the last level, the nodes that do have children are to the far left of the tree. A heap has one other special property that makes it unique, which we call the heap property. The heap property depends on what type of heap we are building, a max heap or a min heap. So let's talk about that. A max heap is a heap in which the root node, or the top of the tree, contains the largest value. So in a max heap, the heap property tells us that for each node, its two children should have a value less than or equal to its parent. Let's look at an image of a heap. We'll see that the top of the heap is 17, and its two children are 9 and 14. Working our way down, we see that the same heap property holds true for each of the child nodes as well. 14 has 5 and 2 as its child nodes, and 9 has 4 and 7. You'll see that in the second level of the heap, 14 has two children, 5 and 2, but 5 is on the left and 2 is on the right. That would not be allowed in a fully sorted binary search tree, but in heaps, it is okay. It still satisfies the max heap property. A min heap is the same except reversed. The root node contains the smallest value, and the value of each tree node is less than or equal to the value of its parent. Heaps are pretty useful when you need to quickly access the max or min elements of a dataset, because based on the type of heap you build, that will always be the one near the top. Heaps are commonly implemented as arrays, and in those cases, the top element is stored as the first element of the array, so we are always able to access the max or min very quickly, since we can directly access it using the first index of the array. A possible issue with heaps, though, is if you need to search for random items, since the rest of the heap isn't really sorted. So if you try to constantly search for random items in your heap, you are going to be dealing with really long lookup times. Now that we know a little bit about heaps, let's start with our implementation. Today we're going to implement our heap using an array, which is a common method of constructing heaps. So we're going to start by creating our class, which is going to be called max heap because we're going to build a max heap today. If you wanted to make a min heap, you could do pretty much everything the same that we're doing in this video, except you would reverse all of the operators so that the min is on top instead of the max. So our max heap is going to have an attribute called data, and that's going to be an array of numbers. And then we're also going to have our constructor, and our constructor is going to take in a parameter data, and that's also going to be an array of numbers. And we're also going to give it a default value of an empty array. Now, when we go into our constructor, we're going to set this.data is equal to ... data. Just like that. Now, if you aren't familiar with this triple dot notation, this is called a spread operation. The reason we are doing a spread operation when adding our data into the heap class is because of the way that JavaScript passes in array data. Arrays in JavaScript and TypeScript are passed by reference, which means that we're not getting a brand new copy of this array when it's passed here. We're actually getting a reference to the original array. That means if we were to just do this.data is equal to data without this spread operation and these extra brackets, and we make any changes to this data, the original data will be changed as well. So to prevent this from happening, we're using the spread operator. And so what this spread operator is saying is that we are going to take each individual element out of this array data and put it in a new array called this.data that is part of our heap. So now that we have our data, let's start building our initial heap. We need two functions, heapify and build heap. So let's start with heapify. All right, so for our heapify function, we're going to take in I as a parameter, which is just an index. And this function isn't going to return anything, so we're going to set the return type to void. Then what we're going to do is we're going to set two variables called left and right. And left is going to be equal to 2 times I plus 1. And right is going to be equal to 2 times I plus 2. And the reason we're doing this is basically a way for us to represent our heap as an array. So this would be the left child of the array, the left child of our current index node, and the right child of our current index. Then we're actually going to set a third variable called largest, but we're not going to initialize that yet. So let's do a conditional. So we're going to say if left is less than or equal to this.data.length. So basically we're just seeing, is this in the bounds of the array right now? And if it is the data that's in the left child greater than the current index data? And if it is, let's set largest equal to left. Otherwise, let's set our current index to largest. And then what we want to do is we want to take this exact same check and run it against the right child. So as long as right is in the bounds of the array, and this.data right is greater than this.data largest, now we're checking against largest, then let's set largest equal to right. All right, so now that we have our check for which child is largest, we want to check to see if largest is not equal to the current index. And if it's not equal to the current index, what we want to do is swap our current index with the largest. Well, we haven't wrote our swap function yet, so let's do that right now. So let's come up here and let's write a new function called swap that takes in two parameters, a and b, that are both numbers. And this is also a void return type. And then what we want to do is create a new variable called temp and set that equal to this.data a. Then we want to set this.data a equal to this.data b. And then we want to set this.data b is equal to temp. So this is a pretty standard swap operation. All right, now that we have our swap, let's come down here and set this.swap I and largest. And then what we want to do is recursively call this function on the largest index. So you'll notice that we're calling this.heapify on the index of the original largest element. And basically, the purpose of this heapify function is to work our way down a single subtree and get the max value of that single subtree up closer to the top. But this alone isn't enough to build our heap. Now that we have our heapify function, we can write our build heap function. And the build heap portion is relatively simple. Basically, what we're going to be doing is looping through our heapify function over and over until our heap is in the correct order. So let's create our build heap function. It doesn't take in any parameters, and it's just going to return an array of numbers because we're just going to return our heap at the end of this. So the idea here is that we're going to start at the last node in the heap that has children. And since we are representing our heap with an array, we know that the left and right child of each node is 2i plus 1 and 2i plus 2, where I is the current index. And since we're using an array, we also know that anything past the halfway point couldn't possibly have any child nodes, because if we're past the halfway point, 2i plus 1 or 2i plus 2 would be out of bounds in our array. So basically what we're going to do is we're going to start at the halfway, around the halfway mark, and go down and progressively sort our array until our heap is in a heap order. So we can do that with a for loop, and we're going to set our index equal to math.floor, and then we're going to take the length of the array that we're storing our heap in and divide by 2 And then we're also going to subtract by 1. And we're just using math.floor to prevent any issues with odd values. And then what we want to do is we want to say, as long as I is greater than or equal to 0, keep decrementing. And then as we go through our loop, we're just going to be running heapify on each value of I. So what this is going to do is this is going to work its way from the last node with children all the way to 0. And it's going to progressively sort until our heap, or the array that's representing our heap up here, is in a heap order. So once this is done, let's just output the value of our heap. We'll call it final built heap. And we'll just print this.data. And then we're also going to return this.data. All right. So now that we have that, we can test what we have so far. So now that we have our build heap function, let's go up to our constructor real quick and call this.build heap right after our data is passed in as a attribute of our class. Then we can come down to the bottom here and make a new heap, and we're going to call it H. And it's going to be a new max heap, and we're going to throw out some values. Let's give it 5, 7, 1, 4, 9, 10, and 3. So since our build heap function is being called in our class constructor, all we should need to do is run our heap.ts, and we should see our heap being printed out. So we'll see now that 10 is the max value in this array that we gave it, and this would be the top of the heap, which means our heap is being built correctly. So if you want to see kind of how the tree view is being handled here, you can kind of visualize it. So this is our first element, which means 2i plus 1 and 2i plus 2 are its left and right children. Well, this is 0. So 2i plus 1 would be 1, and 2i plus 2 would be 2, which means the left child is 9, and the right child is 5, which both of those things meet the heap property because those are both less than 10. Now, if we took 9 and did that same thing, so 2i plus 1 would be 4, and then 2i plus 2 would be 7. We're still meeting our heap property. So 9's two children are 4 and 7. And the same thing goes for 5. 5's two children would be 1 and 3. So we can basically see that it's actually pretty easy and a great way to represent a heap using an array like this. Now that we can build our heap, let's add in some insert and delete functions. But before we do that, let's add a couple of utility functions that are commonly used in heaps. So the first one we're going to do is just get heap, which returns a array of numbers because it's returning our heap. And we're just going to say return this.data or return an empty array. So this is just if our heap is undefined for some reason and we don't want it to end up throwing an error. We're also going to do get max. And we know since we're building a max heap, the max element is going to be the first element in our array. Otherwise, let's return null. Oh, and I should say the return type is number or null. Then we're also going to create a size function, and size returns a number. And we're going to say return this.data.length. And we're also going to make sure that this is not undefined for some reason, or we're going to return 0. And then we're also going to have a function called isEmpty, and isEmpty is just going to return this.data or this.data.length is equal to 0. So this is basically just saying if this thing doesn't exist, return true. So this is basically going to return a Boolean only if our heap data is empty and there's no data in it. So these are a few common utility functions, and this getMax function is a really good example of why heaps are useful. So if we have some program with a data structure where we need to constantly be able to access the max element in some data structure, this is where heaps really shine. So we know exactly where the max element in our heap is, so we can always access it directly by accessing the index of where it's at, meaning that we will get super fast lookup times for the max elements. So keep that in mind with heaps, like that whenever you really need the max or the min values of something, and you always need those values in particular very quickly, that's where heaps are very, very useful in practice. So let's start with our insert function. So I'm going to come down here and we're going to call this function insert, and we're just going to give it a parameter. It takes in a parameter val, which is a number, and we are going to do this pretty simply. Since we are using an array, we can just call this .data.push. And so this is just going to push our value onto the heap without considering where it should go right away. And then what we're going to do is we're going to check what the size of our heap is right now. So we're going to check if this .size minus 1 is equal to 0. If it is, then we don't really have to worry about anything, and we're just going to return this .getHeap. That's the other thing we're going to do, is we're going to return our heap at the end of this. And if it is greater than 0, then we're going to build our heap again. And we know that our build heap function that we built earlier returns our heap at the end of it. So this still works as our return type. So this is just saying if our heap has nothing in it, we don't need to sort it because this is by default the max element of our heap. If it's not, then we need to rebuild our heap. So now that we have our insert function, let's test it out real quick. So we still have our heap h. So let's insert a couple new values. So I'm going to insert 22, and then I'm going to insert 3. So let's run this again. And we'll see that our heap had to rebuild because we definitely have more than one value in our heap right now. But 22 is our new max value, which is because it's much larger than 10. So you can see now that 22 is the top value in the heap. And you'll also see that pretty much everything got rearranged to take into account the rebuilding of the heap. And so we now have 22 as our max, but 10 and 5 are its children. Whereas before, the subchildren of the first were 9 and 5. And now 10 has 9 and 7 as its children, whereas 5 has 1 and 3. So we can see our heap kind of changed quite a bit as a result of entering these new elements into our heap. With our insert done, we can now talk about removing things from our heap. So generally when heaps have delete or remove functions, the deletion happens at the root element of the heap. So that's what we're going to implement today. So let's come up here and create a new function called remove. And remove doesn't have any parameters. And it's also going to return an array of numbers because we're going to return our heap. So there's kind of like a 3-step process here. So before anything, we want to check the size of our heap. And if the size is 0, let's just throw a new error that says heap is empty. We don't want to try to remove anything from an empty heap. So the first step is to grab the last index in our array. So we can do that by calling this.size and then subtracting 1 to get the last index value. Then what we can do is call our swap function. And what we want to do with our swap function is swap the first element in our array, which we know is our max element, and the last element. So now that we do our swap, our largest element is at the end of our array, and we can just call this.data.pop. And pop just takes the last element off an array and returns it, if you're unfamiliar with the pop operation. Now that we've popped our max element off of our array, we can call return this.build heap, because as you can imagine, by removing our max element, putting it at the end and then removing it, our heap is now completely out of order again. So we need to rebuild it. So now we have our remove function. Let's come down here and test it. So since we know we're removing the last element, we know that h.remove will remove 22 from our heap. So let's test that and see what happens. So now that 22 was removed from our heap, we have our new heap, which has 10 as the max once again. Well, I hope this served as a useful introduction to heaps in TypeScript. If there's another topic or data structure you'd like to see me cover, post some ideas in the comments. If you enjoyed this video, please just take a second to subscribe to the channel. Have a great day, everyone.